So here we have part 8 of my electrophilic addition series. And in part 8, we're going to look at halogenation reactions. And a halogenation reaction is the addition of X2, where X2 could be bromine, chlorine. Usually, you don't typically see iodine, fluorine in these scenarios. Um, and the way the reaction works is if you're going to do something general, you'd have something like this. X2, you could say X equals bromine or chlorine on your flashcard, and then on the other side of the flashcard, you'd have again the product. You add X to both sides, and in this case, you could say, this is the halogenation reaction. It undergoes a ring mechanism. There is no Markovnikov or anti-Markovnikov because you're adding the same thing. Rearrangement isn't possible because there's no carbocation, and that it is an anti-addition. Now, in this specific example, there is no, you can't really see that it's an anti-addition, but you could then do another flashcard in which the anti-addition is kind of observed, or I could put X2 here, and on the back, again, have all the same descriptions, but the product here, we would actually see the anti-addition where you'd have the dash and the wedge examples. So let's look at the mechanism here. So the mechanism for this starts with, and I'm going to do it with the ring version, not the simple version, so we can actually see the dash wedge scenario going on. When we do the mechanism for the halogenation, we start with our alkene, and then we're going to add, I'm going to be specific here and show the bromine version. The first thing that happens is the ring or the pi bond adds to the bromine, and then the lone pair from the bromine adds back to form a ring, but we have to kick out this bromine in the process. So 3 arrows are shown in this mechanism in which we get a 3-membered ring. Positive charge on the bromine, technically this is called a bromonium ion. And when that bromine adds, it could add as a wedge or a dash relative to the ring. Both of these have to be a wedge or a dash because, again, it either is going to be above, it's a 3-membered ring, the bromine has to be above or below that ring. Now we generated Br minus in this process. And what could happen is that Br minus is going to add to one side. It doesn't matter which side because in the end we're going to get 2 bromines, but technically speaking, if I had a methyl group over here, it would actually add to the more substituted side. So it would actually add to the side that had the methyl group. But for this example, I'm not going to include that methyl group. We're just going to draw it like this. And the bromine adds anti because the first bromine added as a wedge, the second one has to add as a dash. It has to add from the opposite side because that's the only space in which there is room. The other bromine is going to get kicked out and be a wedge on the other carbon. So when you add X2 to a double bond, you're going to add one of them as a dash and one as a wedge. Again, when you draw your flashcards, I'd recommend 2 just so you can show the point on both that in one scenario, stereochemistry doesn't matter because, well, again, we use X's instead of specific examples. Because there's no stereochemistry here, it didn't matter whether it was a dash or a wedge because you're not going to have a mixture of isomers there. And then you can do another example where the stereochemistry is important. Best to see on a ring, that's where it's easiestly shown. And we would have, again, a dash and a wedge. Now, technically, you get a mixture of the stereoisomers where the enantiomer would also be present, where this one would be a wedge and that would be a dash. But again, it doesn't matter. Because this is a general reaction, when you draw your flashcard, the front could have the general reaction and the back could have, the product as well as a specific example where you make those bromines or something. But again, that's how the halogenation reaction mechanism works, and it's also how I'd recommend making a flashcard. If, again, you want to see more examples, continue on. I will also go through uh, a few more general reactions, which are the halohydrin formation, which starts the same as halogenation, the hydrogenation reaction, and the diol formation.